So actually we have learned about what type of calculus? Predicate calculus. So in predicate calculus, initially I specified something. We always quantify certain things. So what do you mean by quantifying? Some people, all the people, like that, we not only speak about a particular person, we speak about either the whole group in that class. Suppose I take, I'm going to consider about a class. So for instance, I can consider your class. I can either speak about all the persons in the class or some of the persons in the class. So that's called quantifying. So there are two types of quantifiers. One is called there exists. This is always, I think this is a symbol, you know, right? There exists, mathematical symbol. Okay. And this symbol is also a mathematical symbol for all. So there exists X means there exists X, that is X in the universe of discourse, which satisfies certain things. For all X means for all elements in the universe of discourse, certain thing is being satisfied. See, for example, B of X denotes X is brilliant. Okay. So if I write there exists X, B of X, what is the meaning? There exists an X such that he is brilliant, he or she is brilliant, right? Or some X is brilliant. Suppose my X comes from the universe of discourse, the set of all students in the class. Students in the class, no, then I'll say there exists a student who is brilliant. For all X, B of X, no, all the students in this class are brilliant. Or every student in the class is brilliant, like that. So there exists every, for all these things are called quantifiers. Only two quantifiers are there. There exists and for all. There exists sometimes may be called as some. There exists some. There exists at least one. Many ways of saying that. Right? It means all means one and the same. At least one person is there or one X is there which will satisfy that. That's called there exists. For all means that particular statement is true for all values of X. Okay. We read this. See here. For existential quantifier, there exists that symbol. UD means universe of discourse. Universe of discourse means the domain. So we are speaking something, right? Something about whom? That subject comes from this universe of discourse, right? Let the universe of discourse of X be parking spaces at ASV. I don't know, ASV maybe some hotel or something they may mention. Parking spaces at some hotel or some place, some big place where there are parking spaces. That parking spaces I denote that is our universe of discourse. How many parking spaces are there, right? Let P of X be the predicate. X is full. It denotes X is full. Then there exists X P of X means what does that mean? There exists at least one parking space in ASV which is full. That is the meaning. There exists at least one X such that X is full. Where does that X comes from? It is a parking space at ASV. So there exists at least, you have to read like this way. There exists one parking space at ASV such that that is full, or there exists at least one parking space in ASV which is full. Okay, I'll ask you now, what is for all X P of X? Meaning of this?
All parking spaces at ASBs are full.
All parking space in ASV are full. Or every parking space in PSP, ASV is full. that is, there exists itself, they are defined in 3 different ways. Some parking space at ASV is full. There is a parking space at ASV that is full. At least one parking space at ASV is full. All the 3 mean one and the same. Universe. 3 different ways. All parking spaces full. Every parking space, for each parking space, that space is full. 3 different ways of saying all mean one and the same. Very important. An expression like P of X is to have a free variable and what? Bounded variable. 2 things are there. Okay. So here P of X is free variable. It is free means any value it can assume. Okay. There is no, I'm not, suppose if I simply say P of X denotes X is full. I'm not specifying any universe of discourse here. So it is not bounded, but X can be anything. I'm saying X is full. X can be a parking space. X can be a tumbler. I can say tumbler is full. Right? X can be a box. Box is fully packed. Something like that. So I'm not specifying anything here. So here X is free variable. Unless or otherwise it has a quantifier attached to it, it is a free variable. Is it clear? Hello? Hello? Are you all listening?
Yes.
Okay, next. A quantifier either for all or there exist operates on an expression having one or more free variables and binds one of these variables to produce an expression having one or more bound variables. That's what. Whenever you use a quantifier, what happens? It binds one of these. See, for example, X is clever. Clever, I should not say. X is, I'll take sweeter than Y. Something like this. So can you read this sentence? There exists X P of X comma Y. I have given P of X comma Y is X is sweeter than Y. What is the meaning of this? There exists at least one X such that it is sweeter than Y. So which is bounded here? One variable is bounded, the other is not bounded.
Y is bounded.
Huh? Think well and say which is, just now I told you, whenever a quantifier is attached,
X is bounded.
X is bounded, Y is free. Y is free here. Okay. Because that X comes from a particular universe of discourse. There exists an X from some particular thing. But why? I'm not saying where it comes. It is open. Okay. So in this, which is free and which is bounded?
X is bounded.
Y is
Free.
P of X, where X equal to 3 is another way to bind X. Okay, anyway, you are specifying some value for X, right? So it is also one way you are binding X. It is not free to vary. An expression without 0 free variables is a bona fide expression. An expression, very important, an expression with 0 free variables. 0 free variables means what?
All variables are bounded.
Can you speak a little bit louder?
And all the variables are bounded.
All the variables are bounded. Okay. It's called an actual proposition. Okay. So for example, what is this? Is it bona fide expression or bona fide proposition?
No, ma'am.
This one.
No, ma'am.
No, because here y is not bounded.
Ma'am,
Ah,
is it possible to once again explain this free and bounded variables?
okay. Free means, see, for example, I'm saying p of x. That's what I told you. X is full. The same example I did. X is full. So what can be that x? Anything. I didn't specify. What is that x? I'm not specifying the domain from where it comes. If the domain comes from the set of all tumblers, then I can say tumbler is full. Right? I'm not specifying anything. Even you can say parking space is full. Your full box is full. Bag is full. Anything can be full, right? So here nothing is specified. Unless or otherwise it is attached with the quantifier. It is a free variable. So here simply if you say p of x, it is a free variable. Otherwise, suppose if I'm doing something like this, that means I'm attaching a quantifier to that. So whenever I quantify something, there is a universe of discourse. There is a domain to that. There exists an x from somewhere. There exists a tumbler such that the tumbler is full. That means my universe of discourse is set of all tumblers. So it is a bounded variable. I cannot say x is full can be applied to any x. It is only for a set of tumblers. Got
And
it?
this one also applies for all operator.
Which
right?
one?
For all quantifier, this free
Which one? Which one? Can you please
the second.
repeat?
Ma'am, if it is for all x p of x, then that will be considered as bounded.
For all also it will operate. Yes. I can this way also. For all x, that is for all every tumbler is full. That is the meaning of this. If x denotes a tumbler, every tumbler is full. And here if I take two variables, one is attached to the universe of discourse. Y is not attached. Y can take any value. Okay, so y is free to vary. Y is a free variable, x is a bound variable, bounded variable, right? So
Yes, ma'am.
in a yes. So in an expression, if all the variables are bound variables, then it is called a bona fide expression. So this is not a bona fide expression, but this is a bona fide expression because all the variables are bound. So where and all we apply predicate logic. It's a formal notation for writing perfectly clear, concise, and unambiguous mathematical. What do you mean by ambiguous? Confusing, right? It's not clear. So unambiguous means it's clear. So, or it's very obvious. You can understand easily. So clear, concise, and unambiguous mathematical definitions, axioms, and theorems, or any branch of mathematics. So let the universe of discourse of x and y be people. People are a human, right? L of x comma y denotes x likes y. X likes y. There exists y L of x comma y means there is someone whom x likes. Okay, there is some y, or even you can write like this. There is some y whom x likes. Or x likes some y. For all x, there exists y L of x comma y. So everyone has someone whom they like. Can you understand this statement? After all, English statement. L of x comma y denotes. Think whether you can understand.
Ma'am, does it mean all X members like at least one Y member?
Yes. All X members like at least one. That's what. Everyone has someone whom they like. Everyone likes somebody. Everybody likes somebody. That way you can write. Okay. Okay. I'll write now. Use just translate that. How to read this? L of X comma Y, same thing. X likes Y. And now say.
At least one X member likes every other X member.
Okay. Or somebody likes everybody. Correct? Is that right? Somebody likes everybody.
Yes, ma'am.
A dash will have dash free variables. Think about it. A dash will have dash zero. Okay, I'll say here zero free variables. Bona fide expression will have zero.
Bonafide will have zero free variables.
That's what proposition. Another name is. Just it's a review. Whatever we have studied so far, just look into this.
Excuse me, ma'am.
Yes, ma, tell me.
Ma'am, if we write for all, they exist. No, ma'am. Their exist will be covered in for all.
No, no.
Like,
can you please repeat your voice? You are clear, but not you are not speaking.
ma'am, like for all means all X we are specifying. No, ma'am. Like, then why do we need again this?
Why do we need?
There exists X. There exists X. So in the previous case, you wrote both for all and there exists. So only for all is enough, no, ma'am, because for all.
You see that. Oh, here I should have written Y here. Now, okay?
Oh, okay, ma'am. Okay. Yes.
While I'm writing, I made a mistake. Okay, please translate or symbolical statements, you write it in English. Try. X relies upon Y. What do you mean by relying upon somebody? Maybe depending, something like that. What do you mean by relying upon somebody? Exact meaning is not dependent. What is X relies upon Y? Think about it and say, tell. Direct meaning is dependent. For everything, X is what? Dependent on Y. Right? Okay. So for all X, there exists Y R of X comma Y. What is the meaning of this?
All X members depend on at least one Y.
At least one Y. Everybody relies upon somebody, correct? That way you can write. Because X and Y all are humans only. All denote people, human. So shall I write like this? Everybody rely upon somebody, correct? Both mean one and the same. Or everyone has someone to rely on. Okay, no problem. Second sentence, there is some difference. There exists Y for all X, R of X comma Y. You have to say that in a different way. There exists a person Y.
That relies on everyone.
On whom everybody is relying upon. Yeah. I'm just changing the sentence and saying, giving importance to now Y now. Stress is on Y. There is one person Y on whom everybody is relying upon. Okay? Hello? Hello?
Ma'am, can you explain it once?
Yes, ma'am.
Now, what is the first sentence? For all X, there exists Y. For every X, there exists a person Y, such that X relies upon Y. That is the meaning. That is, everybody is relying upon somebody. Second sentence, the same meaning only, but the stress is different. There exists a Y. There exists one person, such that for all X, that is, every X is relying upon that person. So stress is here on Y. You are speaking about Y. So there exists one person on whom everybody is relying upon. Is this clear? First sentence, I am speaking about X. Everybody is relying upon somebody. I am not saying who is that somebody. Here, the somebody is given stress. You are selecting some particular person. There is some person Y, such that on whom everybody is relying upon. Since the first quantifier is there exists Y, you should give first importance to Y. Okay, read the third sentence then. Third one, there exists X for all Y, R of X comma Y. Please think slowly, take time and tempo.
Someone relies on everyone.
Inuma?
Someone relies on everyone.
Somebody relies on everybody. Okay. There is some needy person who relies upon everybody. Okay. Because he is dependent on everybody. He expects something or expects some help from everybody always. Okay. Fourth one.
Everyone is relied upon by someone.
Everybody is relied upon
By someone.
Say it correctly. There is one person on whom everybody is relying upon. One person you are selecting, there is one person, Bechara, that person, everybody is dependent on that person, right? Can you understand this?
Ma'am, it is like there is a X who depends on or who relies on everybody.
Oh, what I'm saying now, am I saying the fourth one?
Yeah.
Fourth one, yes, fourth one, what you have to say? Fourth one, not there exists Y. I said wrongly. Fourth one should be what? For every person Y, there exists an X, such that X relies upon Y.
Ma'am, can we also say it like this? There exists someone who relies on everyone.
Correct.
So ma'am, was that statement right? Everyone is.
That is applicable to third. Whatever you have said is applicable to third. You are giving a stress on what? X. You have to give a stress on Y here.
Ma'am, for the fourth one, was that right when I said everyone is being relied upon by someone?
Can you please repeat? Everyone is
Everyone is relied upon by someone.
relied upon by someone. Okay, 1 minute. I think everyone is relied upon by someone. Okay. I think it looks correct. 1 minute. Okay.
Excuse me, ma'am.
Yes, ma. Tell me.
So, ma'am, it is like this, like X is an entity that is always getting relied, it is dependent one. It wants someone to get rely upon. But Y is the one on which everybody is getting relied.
Yes. So can you say, translate the last one is very easy. For all X, for all Y, R of X comma Y.
Ma'am, everybody relies on everybody.
Everybody relies upon everybody. before going into this. Try this. I'll do one thing. Can you say first one? Everyone likes everyone. It's easy only. Again, the same thing you're going to do.
For all x, for all y,
Uh,
L of x comma y.
okay.
For all x exists y, L of x comma y. For all y exists x.
Ma'am, since they haven't mentioned who likes whom, like they haven't mentioned any variables in those four
The
questions.
preference is not here. So the order usual preference only. First x, then y.
Okay.
Preference is not.
Then ma'am, exists x for all y. L of x comma y. Then exists x, exists y, L of x comma y.
Okay. Okay, we'll go back. Okay, they have given the symbolical notations, right? X, P of x denotes x is a person. F of x comma y denotes x is the father of y. M of x comma y denotes x is the mother of y. So write the predicate x is the father of mother of y.
Ma'am,
Hmm.
how you decided the variables in the previous question, ma'am? I didn't get that. Like it can be x, the x and y can also be swapped, right? How you decided like first is x and
Here,
second is
see,
y?
everyone likes everyone. Here, I think any order you can follow. If L of x comma y denotes x likes y, no, then it should be for all x for all y only. Here there is no specification. See, in the previous question you had some specification, right? 1 minute. Here there is some stress. Can you understand? There is a poor order. I'm here. They are not saying this way. Most probably, if both the quantifiers are same, there won't be any problem. To change also, nothing will happen. The quantifier changes, then there is a problem. Here there is a, see, here there is a stress, right? Can you see the first one and second one? There is a difference. Here everyone has someone to rely on. Everyone means first. You're speaking about the first variable. Here you have changed. So there exists a person, the word itself, the sentence itself changing. You are first saying about that person. There exists a person, Y, such that every X relies upon that person. That way you have to write it in English. Is it okay? That type of thing is not there. You have not changed.
Okay, ma'am, thank you.
Can you understand the difference? 1 minute. I'll go back to that and show you. Suppose here everyone likes everyone. Instead, if they have given there exists a person y, something like that. If the sentence is something like this, there exists somebody who is liked by everybody. Okay. Where L of x comma y denotes x likes y. Now, what is the correct order of writing this?
There exists X.
Oh. Who is liked by everybody?
For y, x, for all x, then L of x,
For all
x comma y, ma'am.
First, you have to start with there exists y. For all x, L of x comma y. So x likes y. So there exists a y, one person, such that who is liked by everybody. He's a very good person. Who is liked by everybody. That way. So instead, if I change the sentence in another way, I'm writing. For example, every person likes somebody. I'm not giving a stress on that somebody, that person. But here I'm giving a stress. There exists somebody, there is one person. So I'm putting that first. Such that who is liked by everybody for all x in the domain, for all x, the humans, x likes y. That is, x is like, that person is being liked by everybody. So what about here? Every person likes somebody. Think about this. How to symbolize this?
For all.
For
all
x.
There exists some y.
y.
L of x comma. Okay. So here only you can see this type of statements. You are not able to say this type of statements. So there is no way of putting y first and then writing x. That is not found here. That's the problem. Okay. Suppose this same sentence I'm writing in another way. Right? Third sentence. All people or all humans are liked by somebody. Already everybody is liked by somebody.
For all y there exists some x.
For all y there exists x, L of x comma. Correct. Okay, now I think you got it.
Ma'am, what if the statement was everyone is liked by everyone?
Everybody is liked by everyone. First one now, which one you are saying?
Ma'am, like if we modify the first one and make it everyone is liked by everyone, then it will be
For all
y.
For all x.
Okay, ma'am.
Yeah. That does not actually mean something new, but the stress differs. The way you interpret, that interpretation will differ, right? Read this first, what and all given slowly. They have actually given P of x denotes x is a person. F of x comma y denotes x is the father of y. And M of x comma y denotes x is the mother of y. So write the predicate x is the father of the mother of y. How do you write this?
Ma'am, M of inside we'll write f of x, comma y,
See,
and
first
then
we
again
need one person in between. Who is that? X is the father of the mother of Y. So X is the father of somebody, and who is the mother of Y? Correct?
yes, ma'am.
Here X and Y are not fixed values here. Just for notational sake, you are writing. I'll write like this. A is the mother of somebody, right? So if you want, you can say this as A and this is B. So A is the mother of somebody. Sorry, A is the father of somebody, and who is the mother of B? A is the father of, you can write like this, some C, and C is the mother of B. Okay, so which is being introduced now? C is the variable that I am introducing here. So here also instead of X and Y, introduce Z in between. So now can you say how to write this? Slowly, say I'm not saying it is easy to understand this. What you have to, you are introducing there exists a person C such that
F of x, comma z,
very good, f of x comma z,
and m of z, comma y.
very good. So there exists a C here Z, there exists a Z, there exists a person Z. So if you want, you can write P of Z.
P of z will also be there, ma'am.
Should also be there. He is a person first of all, right? So there exists a Z such that he is a person, right? And X is the father of that person and Z is the mother of that Y. All these things should be satisfied. That's it. I'm not saying it is easy to symbolize it, but it will be used to when you practice more statements.
Excuse me, ma'am.
Yes, ma'am. Yes, ma'am. Tell.
Ma'am, can we not condense it in one form like f of f inside the bracket x and then comma m, and inside that m function it would be person of z and y. So like z is the mother of y and outside function would tell that x is the father of.
I'm right. Don't use such complications. Nobody will prefer that. Don't use that.
Okay.
I can understand what she is asking is there exists a z, right? P of z and f of x comma z is what? That's what you are saying, right?
Ma'am, like m of, yes ma'am, m of p of z and y. Or okay, p of z is outside.
Every time you need not specify. This P of Z is for everybody. Already you said that Z is a person. You need not specify every time.
Okay.
I'm not saying this is wrong. Don't go for such complicated things. I'm not saying this is wrong.
Okay, ma'am. Yes, ma'am.
So in predicates, can we use connectives as well? Like this?
Of course, connectives are needed. The statement, how would you say X is the father of the mother of Y means how would you actually interpret that statement? X is the father of some person, say Z, and Z is the mother of Y. That is the correct interpretation. That somebody in between is missing, so we are introducing a variable that exists because it's not visible. Some that person name or something is not given, so you yourself say there exists a person. That and is necessary. Otherwise, there is no meaning in that particular statement.
Okay, ma'am.
Okay, all cats are animals. I'll give you the sentences. You tell me. See, C of X denotes X is a cat. A of X denotes X is an animal.
For all C of x, A of x.
For all. Hey, how do you interpret this statement first? Just like X is the father of the mother of Y, can you interpret this statement? Is it a single statement? When you want to symbolize this, you have to, how to write this?
All x are cats and all x are animals. All cats are animals, sorry.
And all cats are animals, sir. All cats are animals. I'll say like this. Whenever X is a cat, if X is a cat, then X is an animal. Is that correct?
Yes, ma'am.
Or X is a cat and X is an animal. Which is right? I'll write two sentences. Which way the interpretation is good? If X is a cat, comma, then it is an animal. Is this the correct interpretation? Or X is a cat and it is an animal. And X is an animal.
The first one is correct.
First one is correct. Why second one is not correct?
One.
Why second one is not correct?
Because
I
in
mean,
the
it can
first
be
one,
anything.
X should be the cat to
First
become an
it
animal.
needs to be a cat. Very good. It needs to be a cat because you are saying all cats are animals. So you cannot assume X is a cat and X is an animal. That means you are assuming yourself, right? So if X is a cat, then X is an animal. Okay, how do you write this then? Using quantifiers. You understood. That means what? Whenever X is a cat, it is an animal. So whenever X is a cat means what? For all X, right? If X is a cat,
Implies.
It implies, ma'am.
correct. Is this right, this sentence? Hello? Can you understand this?
Yes, ma'am.
Sure. So whenever X is a cat, why for all X? Whenever X is from cat family, right? For all X in the domain, you check whether if it is a cat. If it is a cat, then it is an animal, right? Okay, I'll stop here. Anyway, its time is up. What is the time now? Time.
26, ma'am.